Hi, welcome to my video on defining a point, ray, line, line segment, angle, and adjacent angles. Those are all the definitions that will be in this video. Point, ray, line, line segment, angle, and adjacent angles are in this video. A point. A point has no size, but is represented by a dot that does not have size. Points are named by capital letters. So we take this and call it A. You can take this one and call it B. You can take this one and call it H. They are points on the place, but they have no size. A line, definition of a line consists of an infinite number of points. So if you take all the points and put them down like that, and eventually the line will be shaded in. So we have this line designated by an L, so it's called line L. This is another line with many points on it, but 2 points are on this line, A and B, so we name the line as AB, line AB, or we can call it AB with a line above it. So a line has 2 endpoints, 2 arrows on each end, moving, not an endpoint, it has 2 arrows on each end moving in opposite directions. Let's define a ray. A ray is a part of a line. It has an endpoint and all the points in one direction. So notice this ray here starts at P and goes to Q. So that's the ray PQ. So we start with the endpoint, or we can call it PQ. Notice the dot is there, moving on to the right. Even though this ray is the ray XY, when you're looking at a diagram, the ray starts, X is the starting point, the end point of the ray. So ray XY, even though it's pointing to the left, when we name it, we start with the end point first, and then we look at the diagram to see where the ray is going towards. So we know it's going from X out towards Y. Note the end point is first. A pair of opposite rays with the same endpoint form a line. So if you take the ray PQ, so this is the line, we can say that's the line TQ if we want. The line TQ. The opposite rays are PT, PT, and PQ. So note P going to T, P going to Q, they're moving in the opposite directions. So two rays with the same endpoint form a line. A line segment. A line segment has 2 endpoints and all the points in between the endpoints. So notice the line segment is cut off, it's a part of a line, and this is the line segment EH, or you can go EH with a bar, and the bar indicates a line segment. And if you see up here, that's AB, but it's a line, and that 2 arrow is on the end. An angle. An angle has 2 rays with a common endpoint. So an angle has 2 rays, the ray OB and OA. So it has the rays OA and the ray OB, and the common endpoint is called its vertex. The common endpoint we say is the VERTEX. So 2 rays moving out from a common endpoint form an angle, and we name this angle as angle AOB. And notice that the vertex is in the middle. AOB, the vertex when you look at an angle. An angle can have 2 segments with a common endpoint. So this angle, if you want, is named from, this is the angle VYW. Again, Y is the vertex. An angle has 2 segments with a common vertex. An angle can be named by a number. So sometimes we can say this is angle 1, or we can say that's angle 2, etc. Or we can name an angle with a letter like small a for an angle. small b. You'll see that as we go on in the geometry. Sometimes it's easier to name angles with numbers when we're talking about them in a diagram, especially when we go to do proofs. That's one of the videos, or one of the units on congruent triangles. Doing proofs, we name angles with numbers. Let's continue. Let's see if we can, from this diagram, use the diagram to name each. Can you name 4 points? Well, they've got an A, a B, an F, and a C. So we have A, B, F, and C. Now you can name them in any order, but they're points. Point A, point C, point B, point F. A line has to have an arrow on each end, so therefore the line is AF. Or we can call it BF. Or we can call it, I got AF, AB. So any 2 points on a line can name that line. So this line has 3 different names, but they all mean the same thing. So if I say the line AB, F is on that line, so they're the same. Name 3 rays. So I have to have an endpoint. So I can't go CB because it doesn't go on that way. I can go FA because it starts F. So if we want, we can say the ray BC. We can say the ray BF. We can say the ray BA. Notice I started with the endpoint moving in one direction. Start with a point moving in one direction. Start with a point moving in one direction. If I want, I can say a ray is AF if I wish, because I have an endpoint moving in one direction. I can say the ray FA if I want. So as long as I start with a point and move continually in one direction. Opposite rays that are rays with the same endpoint. So the only opposite rays are BF and BA. Notice B is an endpoint. Notice the two of these, notice that BF and BA joined together will give you a line. 4 line segments. Let's name 4 line segments. Well, I can go AB is 1 line segment. I can go BF, and I can go BC, and I can go AF. So when I say AB, I only mean that part from there to there. When I say BF, I mean just that little piece from there to there. BC as a segment is that part of a line from there to there. So it's a part of a line. It's cut off. And AF is this segment from there to there. It doesn't go on. Name 3 angles. So we have to have a vertex in the middle. So we can say angle A, B, C. Angle A, B, C. There's an angle. There's the 2 rays. BA, BC with the vertex in the middle. Another angle could be FBC. Angle FBC. Another angle could be, and I have this one, it could be angle ABF. That's an angle, because B is the vertex in the middle. And we could also name the angle ABC. We could also say CBA. So ABC is the same as CBA, and FBC is the same as CBF. So I can say that's CBF. Or I can do this one as FBA. I can say, right, I can say FBA or ABF. So notice these angles are the same. They have the same vertex with the same rays. Now, adjacent angles. Adjacent angles are 2 angles which have a common vertex, a common side, which could be a ray or a segment, line segment, and again, no overlapping. There's two angles that join each other with the same vertex, same common side, with no overlapping. No overlapping means no points except the common side. So the points inside of one angle is different than the points inside of the other, so there's no overlapping. Let's go through some examples. Here we have the ray AB, AC, AD. So the adjacent angles would be angle BCA, and let's name that an angle, and angle DAC. So notice these two angles right here, this one and this one. You got completely different. So the common vertex for both of those is, did I say BCA? I should have said B, my mistake, BAC. Notice that's BAC. Because I need a common vertex called angle A. I need a common side called AC. So A is the vertex for both of these angles. Notice A is in the middle. So I got BAC, DAC. So there's the two angles, that one and that one. I mark them. Notice there's no overlapping. There's no shading. But if I said BAD and CAD, if I did that, watch. If I said BAC and BAD, BAD would be that one. There's BAD. So notice I got these two. So notice that this angle, that angle there, is in both. So that's not adjacent. Adjacent angles are alongside of each other. Adjacent angles here are angle EFH, EFH, and I could say HFG if I want. Again, notice EFH is this angle and HFG is this angle, and they have a common vertex called F. Vertex, I got an angle symbol, but this shouldn't be an angle. Common vertex is F. F is a point. A vertex is a point. I shouldn't have an angle either. The vertex, remember, is a point. Common side is FH. And the common side here is a segment, but I don't want to get hung up on, that's a bar. So that's a ray, that's a segment. Again, go back, common vertex for these two angles is A, not angle A. And in C, I want adjacent angles. Well, there's many adjacent angles here. Just take two angles. I could take this one and this one. I could take that one and that one. So I could take those two. I want to notice I got one stroke, I got two strokes. Here I got 3 strokes, 4 strokes. I can't, if I mark one stroke here and one stroke there, I'm saying in math that those angles are equal. So a pair of adjacent angles are these two, or it could be these two. So I'll just do one pair. So angle PTQ and angle RTQ. Again, notice that T is the common vertex. T is in the middle. And the common side is TQ. And TQ is a segment. And down here, adjacent angles, 1 and 2. So if I want to put an A there and a B there, I do that because I have to name this ray. So if I say angle 1 and angle 2 are adjacent, what I'm talking about, when I say angle 1, I mean that angle there. When I say angle 2, I mean that one there. Because you can't say angle 1 and mean it for all this. So when you number an angle, it's only for the smaller part of the bigger angle. So I have a common endpoint called A, and I have a common side, AB. So 1 and 2 are adjacent. Again, you get the idea that adjacent angles have same vertex, same common side, no overlapping. Now, why are these angles not adjacent? Angle AOB, well, let's mark it, AOB. Angle AOC, AOC is this one. So you can see when I got those marked, they both have the same vertex. They don't have the same side. So again, they don't have a common side, so there's no common. Oh, yes, they do. I'm not careful enough. They have OA as the common side. Look, AO. The ray OA is the common side. So why they're not adjacent is there's overlapping. So just be careful. There's overlapping here. So angle AOB is also included in the angle AOC. But they do have a common vertex, right? O. They do have a common side, OA, 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 but there's overlapping. Number 2, why are these two not adjacent? Let's see. AOB is this one, and COE, that one. And you could say, well, they have a common vertex, which is O, but they don't have there's no common side. So they're not overlapping. There's a gap between the two of them. And number 3, ACH. ACH is this one. And CET. CET is this one. And what do they not have? Well, there's a couple of things. They do not have the same vertex because the vertex is C and E. So the vertex right there is C. The vertex right there is E. So vertex, not the same. And also, they do not have a common side. There's no common side. So angles are adjacent, and you'll see it in the geometry and the proofs and everything we're going to do, that adjacent angles are two angles that are joined to each other with a common side, common ray, common segment, and they have the same endpoint. Again, these are adjacent. These two, I gotta be careful, these two are adjacent. If I do that, then there's overlapping. That's my first video. I'm starting off the section on geometry. And this section is, this geometry I'm doing is geometry on the fundamentals of geometry. So I'm going to explain all the basics to get you working on when we do proofs and things like that. So if you like my video, click on the like button, the subscribe button, the notification bell. Write a comment on my video if you wish, and visit my math website, mathfullyexplained.com. And you get information about me, which my degrees in teaching experience. In the section on videos, you'll see the teaching strategy you're going to use to help you learn. And in the section on content, you'll have the topics and the number of videos on each of those topics. And the black font is the topics that are online, and the red font is the topics I will be doing in the near future. Thank you very much. Bye-bye.